Alright, so we are going to do some amplitude and period adjusting in this video that's going to look at tangent, cotangent, and the reciprocal functions of sine and cosine, which are cosecant and secant, respectively. So let's first of all work with cotangent. And this time it's going to be 3 cotangent of x. Alright, now I made 2 graphs in case you made a mistake on one, but let's put in our asymptote lines. There's an asymptote line here at x equals 0, and there's another asymptote line here at pi, or x equals pi. So I'm going to put that here, x equals pi. And there's going to be another asymptote line here at x equals 2 pi. Now you see me filling out some of this up here in the points spot because I'd like you to pick 5 points that are part of the problem, although I'll be labeling each of these for you just in case you picked something different, because on your test you're going to have to pick 5 pretty points, and you can choose asymptote lines as a good substitute for a point. The cotangent is a high, medium, low pattern. Swoops up from the center here and then swoops down here, like so. And you're not a computer, so little variances should be no problem. Okay, here we go. Alright, let's get these black bars out of the way here. Come on there. One's going to go away just a bit here. So let's do domain. The domain is going to be all of the x values except for the asymptote lines at 0 pi, 1 pi, and 2 pi. So I'm going to write this in set notation form. X cannot be equal to k pi, where k belongs to the set of integers. So that's again a z with a little a second line for it. And let's close off my set notation. Now the range is going to be all real numbers, or we can use interval notation to go from negative infinity to positive infinity. We didn't have any adjustments to the vertical shift, so our midline is going to be y equals 0. We didn't have any phase shifting. Our period was our normal pi, which is true for tangent and cotangent. The period is pi, since there were no period modifiers or numbers in front of the x, and the amplitude is 3. So let's actually put our amplitude of 3 and negative 3 and 0, and let's label all the other points, even though on the test I would only require 5. So the first point is going to be at parentheses, pi comma 4, which is our new gap, which is right here, pi comma 4, pi comma 4 comma 3. The next point is going to be at 2 pi over 4, which is pi over 2, comma 0. And the next one is going to be 3 pi over 4. 3 pi over 4. Sorry, that's looking a little sloppy there. Over, or a comma negative 3. So 3 pi over 4, comma negative 3. This is 4 pi over 4 at this asymptote line. And then 5 pi over 4, comma, back up again here at 3. 6 pi over 4 is reducible to 3 pi over 2, and you must reduce your fractions. 3 pi over 2, comma 0. That was 6 pi over 4, and then we got 7 pi over 4, comma negative 3. Alright, there it is. There's everything for problem number 1 on this amplitude of 3 for cotangent. So, we now have cosecant with an amplitude of negative 2, and we have to remind ourselves what happens when we have a negative amplitude. Well, when you have a negative amplitude, first of all, you should report it as an absolute value of that negative amplitude, which in this case is 2. Cosecants have asymptote lines at these locations, including x equals 0. So x equals 0 is an asymptote line, which I'm going to put down here as one of my points. And then we'll have skip a space, and then we'll have another asymptote line. Since this is pi over 2, this would be x equals pi. The next one here is x equals 2 pi. Whoops, I wrote 24. That's just silly. 2 pi. And then this one here is x is equal to 3 pi. And then finally at the very end, x is equal to 4 pi. Check it out, man. So what we're going to do now is we're going to have our 2 and negative 2, and reminding ourselves that the amplitude, if it's negative, normally for the sine and cosine wave, you would go in the opposite direction. Well, think about it the same thing with cosecant. Normally, it would be up here as a smile. Well, the negative amplitude will make it start out as a frown instead of a smile. And then we have a smile instead of a frown, and so on and so forth. Okay, and there is my, and let me put my points in here, like so. And I can actually write the points down. Again, you would only need 5 on a test, but I'm going to put in all 9 dots here just to show you what you could have chosen. This is going to be pi over 2, comma negative 2, pi over 2, 2 pi over 2, 3 pi over 2, 3 pi over 2, comma 2, 4 pi over 2, 5 pi over 2, comma negative 2, 6 pi over 2, 7 pi over 2, comma positive 2. Okay, the domain. So the domain is going to be everything except this pi over 2, 2 pi over 2, 3 pi over 2. So like the problem up above, it's going to be the same domain. X is not going to be equal to k pi. Oh, I'm sorry, it's not the same. Oh, yeah, just k pi, and that's going to be, it's right. K belongs to the set of integers. Okay, now let's close off our little set notation and go to the range. The range is going to be a little different. Instead of all real numbers, we have everything but this no man's land and between the two smiles and frowns. So what we're going to have is the set between negative infinity and negative 2, close bracket, union, 2 bracket, positive infinity. Now we didn't have any vertical shifts, so the midline is going to be y equals 0. We didn't have any phase shift, and the period stayed the same at 2 pi. We're not going to see any period differences until the next problem. And the next problem is going to have some effects to the period. So to round out this video here, we are going to do 3 examples of changing the period. And we might, for the last example of this set, we're going to also affect the amplitude. So let us work with our first period change of tangent. Now the first thing you should do is probably plot in your normal points for tangent. So the origin, this point here at 1 and pi over 4, and then we have an asymptote line here. And this goes up like that. Then we have low and medium to our first period, and this first period ends at pi, and then this cycle repeats again. I'm going to choose a different color just so you can see that here. We'll have another asymptote line. So the green side is going to be an exact copy of the blue side. So you can see that we have now 2 periods in a span of 2 pi, whereas for a normal sine, cosine, or cosecant, secant, we would have 2 periods inside of 4 pi. So our amplitude is going to be 1. And don't put a 0 in for amplitude, because that would just multiply by 0 and just quickly delete everything. Our points, we don't want to put any of those down because we want to affect the period first. And the period is going to be pi in this case, divided by the absolute value of b. Now you'll note that when we were dealing with sine and cosine, it was always 2 pi divided by the absolute value of b. But since we're dealing with tangent and other times cotangent, this is going to be my new period formula. Pi divided by b is going to be then pi divided by 1/2, which is another way of, I can manipulate that here. I can go pi times, skip, flip, multiply, 2 over 1. So this means that my period is now 2 pi. So the period is 2 pi. So instead of this being pi, it's now 2 pi. Now what's nice about this is this kind of brings us back to what we're familiar with, a gap of pi over 2. This brings us to, hold on a second here, pi and 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, which is 3 pi, and then 7 pi over 2. Okay, so this brings us to all of these coordinates. Now, you could spend time copying this graph over onto this, but in fact what I'm going to do is I'm going to just label my points based on what's over here and where these coincide over here on my graph. So the origin is 1. Then my next point would be pi over 2 comma 1, because there's my 1 and negative 1 here. So pi over 2 comma 1. Then 3 pi over 2 is an asymptote line, so x is equal to 3 pi over 2. And then what we have after that is at 2 pi, we have 2 pi comma, hold on a second here, 1, my asymptote, whoops, made a little mistake there. My asymptote line is at pi, excuse me. So there's an asymptote line here at pi. So maybe it is good that I kind of quickly do this, because I just see I just made a mistake in trying to transfer it without putting in the work. Perfect example of being a little bit less, being a little lazy and having it cost me more time just to fix it, right? So there's my x is equal to pi. Then I have 3 pi over 2, comma, negative 1. Put that there. And then what we have is 2 pi comma 0. Then after that is 5 pi over 2 comma 1. X is equal to 3 pi. That's the second asymptote line here. And we have then 7 pi over 2 comma negative 1. And then finally 4 pi comma 0. So there we have it. There's all 9 points. And you could pick 5 of those for your pretty points on your test. So what is your domain? Well, it looks like I have an asymptote at pi and 3 pi, and we'll have another asymptote at 5 pi, 7 pi, and 9 pi, and so on and so forth. So here we have x cannot be equal to k pi, and k is odd. I don't need to say it's an odd integer. We're kind of assuming that when we see the word odd. The range is going to be all real numbers, or you can use interval notation, negative infinity to infinity. That's nice because it goes infinitely low and infinitely high. The midline is y equals 0 because we had no vertical shift in this problem. And we had no phase shift in this problem either. So this kind of brings us to the amplitude of 1, the period of 2 pi, phase shift of 0, and the vertical shift of 0. Now let's do another problem, and we're going to deal with cotangent this time, and we're really going to mess with the period because we're going to use a radian this time. So for this example here, we've got the cotangent of pi over 4x. Now it's very much a bare bones problem here. We don't have to deal with anything else really other than the period. So let's put in our amplitude as 1 and negative 1. So amplitude is now done. Let us take care of the midline, which is y equals 0. And the vertical shift is 0. The phase shift is 0. But we need to figure out our period so we can do our points and then do our domain and range. So I'm going to start off with drawing the points of cotangent. We have an asymptote line there. And then here we have our high, medium, low. Swoop up going this way, swoop down going this way, and this is an asymptote line. One asymptote line at the end. Okay, swoop up this way, swoop down this way. Like that. Okay, so we got our 1, negative 1. It's time to have some fun. Let us do our period, which is going to be pi divided by b. And the b in this case is going to be pi over 4. So pi divided by pi over 4 can be rewritten as pi, skipping the first part, flipping the second part, 4 over pi. And there we go. So we simplify these pi's and we get an answer of 4. Okay, so it looks like my new x-axis is 4. So this is going to be our period right there at 4. Let me change colors so it's a little easier to see. There we go. So our period is 4. That means we go 1, 2, 3, 4, 5, 6, 7, 8, which is pretty awesome. So getting our points is going to be super easy. X is equal to 0. This is the point 1, 1. Next point is going to be 2, 0, 3, -1, and x is equal to 4 is the next asymptote line. Then what we have next is 5, 1, 6, 0, 7, -1, and then x is equal to 8. Okay, so it looks like my domain is going to be a little trickier to write, so I want you to think about this setup here. So it looks like 0, 4, 8, and I'm going to assume 12. After 12 is 16, after 16 is 20. So it looks like it's going up by 4s, but another way to think of it, it looks like my asymptote lines are multiples of 4. So x basically can't be anything that's a multiple of 4, or 4k. So that means k times 0, k times 1, k times 2. Sorry, I said that wrong. 4 times 1, 4 times 2, 4 times 3, 4 times 4. Basically, if k is any integer, then this is going to be an asymptote line. So k belongs to the integers again. Again, that's a z with a line through it. You've seen these. You may have seen these before, but that is the mathematical symbol for integers. So the range in this case is going to be all real number. And again, what's fun about that is you can use interval notation here. And it's all real numbers because the y can be as high as infinity and the low as infinity as well. So, cool. 2 down, 1 to go for our period adjustments. So let us go to the next graph here. So for our final problem here, let us take a look at messing with secant. And we're not only going to mess with secant, but we're also going to mess with the period. And we're going to have an amplitude that's in the negatives as well. So this is going to flip things. But what we can do right away is we can put our asymptote lines in, just like our asymptotes were put in there for the previous problem. And since this is a negative amplitude, normally we'd have a half smile, then a frown. So what we're going to do is have a half frown and then a smile, like so. Then another frown, and then a smile. Sorry, that's a little crooked there. And then another half frown. There you go. This gives us our correct shape for this graph. And before I put the points in, let's take care of our amplitude, which is 3. We are not going to put that down as a -3. Amplitudes are always reported as absolute value. Got to figure out the period, though. So we're going to go to our 2 pi divided by b. Now, the reason why we're back on 2 pi again is because everything except for tangent and cotangent has a period of 2 pi. So when using our period modifier, which is b, we have to use our formula, which is 2 pi divided by b. And 2 pi divided by b is going to be 2 pi divided by pi over 2, which can be rewritten as skip, flip, and multiply. So the pi's simplify. 2 times 2 is 4. So here we have another really nice period as 4. And that would mean this is 8, and everything would go up by 1. So 1, 2, 3, 4, 5, 6, 7, 8. Let's do our points in this problem. And let's do our points from left to right. It looks like our first point here is going to be at the y-intercept. This is 0, -3. Then we're going to have x is equal to 1. Then we're going to have the next point, which is 2, 3. Then the next point is going to be x is equal to 3. Then what we have is 4, -3. x is equal to 5. That is my asymptote line equation. And then what we have is 6 comma positive 3, x is equal to 7, and then 8 comma negative 3. The domain is going to be where all of these asymptote lines are. So the asymptote lines are at the 1, 3, 5, 7, so you can kind of figure that out pretty quickly, that your x cannot be k. Notice there's no pi with this since these are all integers here, but the ones we don't want are the odd integers. So here k is odd. And the range is going to be not all real numbers. So the range is going to be from -3 to -infinity and 3 to positive infinity. Make sure you write these the correct way. -infinity to 3 bracket union bracket, sorry, -3. Make sure there's a negative in front of that 3. And then we're going to go from +3 to infinity, parenthesis. Now there's no vertical shift, so the midline is y equals 0. The period did change to 4, and the phase shift is 0.